Alright guys, for these first 6, we're going to be using our geometric formula, which was a sub n equals a sub 1 times r to the power of n minus 1. And so a1 is really the first term, as a quick reminder. And then r, remember, is a2 over a1, or actually any term divided by the term in front of it. Okay, so for number 1 here, obviously a1 is negative 3, and r is negative 9 over negative 3, which is 3. So I can set up my formula as negative 3 times 3 to the power of n minus 1, and that's it. Now, this one also asks for a sub 12. So a sub 12 now is pretty easy. If I have my formula, I'm just going to do negative 3 times 3 to the power of 12 minus 1. So it's going to be negative 3 times 3 to the power of 11. I would just type that in my calculator just like that, and it comes out to negative 531,441. Just that. All right, next step here. This is given the recursive formula. And so this one is asking us to write the first 5 terms. So I already know the first term is negative 128. And then the recursive formula just says do this each time. So each time we're going to multiply this by negative 1/2. So if I multiply that by negative 1/2, that's going to be a positive 64, just times 1/2. And then if I times, negative 1/2. If I times negative 1/2 again, it's going to give me negative 32. And then if I do it again, it's going to give me a positive 16 and then a negative 8. And then it wants the explicit formula. So now it wants this formula back up here again. So that's going to be a sub n equals the first term, negative 128, times r. Now r is going to be 64 divided by negative 128, and that is negative 1/2, or negative 0.5. I'll go ahead and use negative 1/2 to the power of n minus 1. All right, next up here, number 6. So for this one, for number 5, it gives me day 3 and day 4. Now, for this one, what I would do is I would set it up as A1, A2, A3, A4. And so I know day 3 is 10609, and then on day 4 it's 10927.27. So I can actually figure out what R is, because I can divide anything by the term in front of it. So I got 10927.27 over 10609. So once again, I would do that on the calculator. It comes out to 1.03. And so that means that's my R. So you multiply by 1.03 going that way, but that would also mean that you could divide by 1.03 going that way. So I'm going to go do that in my calculator and fill out the rest of them. So 10609 divided by 1.03, and that's 10300. And if I divide that by 1.03 again, it's going to give me 10,000. So I know my first term is 10,000, so now I can write my formula as a sub n equals 10,000 times 1.03 to the power of n minus 1. All right, next up we're going to solve these and check for extraneous solutions. So I'm going to start off by squaring both sides since my radical is isolated. So I have 110 minus m, because the square root and the square just cancel each other out, and that equals m squared. So now I'm going to get one side to 0, so I'm going to add m. I'm going to subtract 110. I always like to keep my squared thing positive, so I move the other stuff over. All right, and now I'm going to factor. So I'll go ahead and use a diamond here. Thinking of two numbers that multiply to a times c, which is negative 110, and add to 1. So that'll be negative 10 and positive 11. So that's how I split up the middle term. So m squared minus 10m plus 11m minus 110. And I'll do my grouping here. So the first group I can take out of m, leaving me with m minus 10. Second group I can take out of plus 11, which leaves me with m minus 10 as well. So I have m plus 10, no, m plus 11, m minus 10 equals 0. So that means that each of these individually equals 0. So m would equal negative 11. And then m would equal positive 10. But I do have to check these for extraneous solutions. So that means plugging them back into the original equation way back here. So if I do the square root of 110 minus negative 11, does that equal negative 11? So I plugged it into both of those m's. So this is the square root of, that's actually plus plus, that's 121 equals negative 11. That's 11 equals negative 11. So that's not true, so that means this is an extraneous solution. Whereas this one over here says the square root of 110 minus 10 equals 10. So the square root of 100 equals 10. And 10 equals 10, which is certainly true, so that's my only answer. All right, next up here, I'm going to use my magic points. So I'm going to use my 0, comma a, and then 1, comma a times b. So for this one, that's going to be 0, comma, and this is a, and that's b. So 0, comma 4, and then 1, comma 8. And we just draw a quick graph right there. That's good enough. All right, next up here, same idea. I'm going to start off with my 0, comma a and 1, comma a times b. Now this one's a little trickier because, oh, actually a is 1 here because there's a 1 out front, and then the b is 1/4. So then got 0, comma 1, and then 1, comma 1/4. But we do have transformations here. So we have the x plus 1 up there, so that means we need to subtract 1 from our x's, and then I have a plus 2 out there, so I need to add 2 to my y's. So this is going to become now negative 1 for my x there, because I need to subtract 1 from 0. 3, because I need to add 2 to y. This one will become 0, and then you can do this one as 2.25 if you like, because we're just think of that as 0.25, and then we add the 2. Okay, so negative 1, comma 3, and then 0, comma 2.25. So that one's going to be a decay here, going down like that. All right, lastly here, we'll grab a couple points here. We can grab 0, comma 4, and 1, comma 2. And I can remember that it's always 0, comma a, and then 1, comma a times b. So clearly a is 4. And then a times b would equal 2, but I know that a is 4. So 4 times b equals 2. Divide by 4. B would equal 1/2. This makes sense since it's decay, that b must be less than 1. So y equals 4 times 1/2 to the power of x.